Hello, my name is Rosemary Flores,
Hi, I'm Kristen.
I'm Felicia,
and we're here to discuss Experiment 3, which is the determination of a chemical formula. A chemical formula is extremely important in chemistry so that it identifies the amount of each element in a compound. For example, H2O, there's 2 hydrogens and 1 oxygen.
In this experiment, the law of definite proportions is used to find the chemical formula of a hydrated compound containing copper, chlorine, and water molecules locked in the crystal structure of the solid compound. Determination of the water in a copper chloride hydrate sample is our objective, as well as to conduct a reaction between the solution of copper chloride and solid aluminum, to use the results of the reaction to determine moles of copper and chloride, and then to calculate the empirical formula of the copper chloride compound.
When conducting any experiment, not just Experiment 3, it's important to wear your safety goggles, apron, a short sleeve t-shirt at least, and long pants to ensure safety. Also, gloves, just in case, and closed-toe shoes.
So before you begin any experiment, it's always necessary to weigh the items needed. So this is the crucible at a weight of
18.39 grams.
The watch glass weighs
88.8 grams.
and then the filter paper weighed 2.25 grams. First, we weighed the crucible with the hydrated sample in it at a weight of
19.33 grams.
Push it my way. Then we set up the Bunsen burner, lit it on fire, and waited until our sample turned brown because it originally started blue. Then we reweighed the sample a second time,
Which it weighed in at 19.10 grams with the crucible in the anhydrous sample.
Yeah, that was the mass of the hydrous sample. Okay, so the anhydrous sample, which was the brown we just did, was 19.10 grams. So therefore, the anhydrous sample was 0.71 grams. So the amount of water that was released from the burning of the hydrated sample was 0.23 grams. Then we took the sample. Once the hydrated sample has been burnt to become an anhydrous sample, we dump that into our little 50 ml beaker. We add 2 increments of an 8 milliliter DI solution. So there's the first one. There's the second one. Now then, we took our copper sample and we placed it in here as well. Once we have that all mixed up, we dump it right here inside of our filter to produce a gravitation filtration. If you can see the water trickling down through our filter. And so therefore, then we were able to separate the copper from the aluminum. Once this dried out, and by placing it onto our watch glass, which I'm going to make this a little faster by dumping my water out. Well, I'm just making it faster. Placing it onto my watch glass, allowing it to dry, and then measuring the filter paper for the remaining copper. Once we're pulling the aluminum out and then having the remaining copper.
Now, another thing that's important is once it dries and we measure the filter paper, we subtract this measurement. We subtract the original filter paper measurement from the overall measurement to get the actual mass in grams.
The mass of the watch glass with copper weighed in at 89.28 grams. So therefore, the massive copper, by the time we subtracted the watch glass and filter paper, was 0.47 grams.
So after the heating of the hydrous substance that becomes the anhydrous substance, we place it into the 50 ml container. Once in the 50 ml container, we add the aluminum, and then we also add the 2 increments of 8 ml distilled water. From there, we add 5 drops of 6 molarity hydrochloric acid to our solution. Once we have added the 6 ml, or the 5 drops of 6 molarity, we pour it into the filter paper. And then we take ethanol to finish cleaning out the residue from our 50 ml, and in order to help with the filtration. Once we finish that, we remove the filter paper and lay it upon our watch glass and allow the substance to dry. Once it is dried, we can remove any remaining aluminum and then weigh the substance to get our final copper